Welcome back. In this lecture, we are going to understand a little bit about Kubernetes architecture. So, why Kubernetes? So, Kubernetes is a portable, extensible, open source platform for managing container workloads. So, out of the box, the following features are available in Kubernetes: service discovery and load balancing, storage orchestration, automated rollouts and rollbacks, automatic bin packing, self-healing, secrets, and then configuration management. So let's see what are the Kubernetes components in its architecture, right? So primarily we see like we'll have both master and then worker nodes in the Kubernetes. And on all these nodes, we'll have the container runtime installed. Whether it is master or worker nodes, container runtime is mandatory. And we can say it as Docker or some other container runtime options available. And next thing is eksctl. So eksctl is the key value store which stores the master and node information. So one more will be kubectl. So all these things, what does these do? We'll see in our upcoming lectures. So but we'll have kubectl here and kube API server and kube control manager and then cloud control manager. So that's the master components on a high level. And in worker nodes, we are going to have kubelets and then kube proxy. So let's see one after the other what each of these components do and then their responsibilities. Okay, so let's start with the master component and then master node, and inside that container runtime is a default thing, so which might be Docker or any other runtimes. And let's start with the kube API server. So it acts as the front end for Kubernetes control plane. It exposes the Kubernetes API. So CLI tools like kubectl or even the master components like scheduler, controller manager, etc., and worker node components like kubelet, everything talk with this kube API server. And next is eksctl. It is a consistent and highly available key value store used as Kubernetes backing store for all cluster data. It stores all the master and worker node information. So next is the kube scheduler. So scheduler is responsible for distributing containers across multiple nodes. So it watches for newly created pods with no assigned node and selects a node for them to run on. And next is the kube controller. So this kube controller manager, controllers are responsible for noticing and responding when nodes, containers or endpoints go down. So they make decisions to bring up new containers in such cases. And it is a combination of kube controller manager is a combination of multiple controllers inside. Okay, so let's see what are those. So we'll have one node controller which is responsible for noticing and responding when nodes go down. And we will have replication controller responsible for maintaining the correct number of pods for every replication controller object in the system. And endpoints controller populates the endpoints object, that is joins, services and then pods. And one more, we'll have something called service account and then token controller creates default accounts and API access for new namespaces created in Kubernetes. And next one, we'll have one more which is nothing but cloud control manager in the master nodes. Okay, so this cloud controller manager is responsible for, means like this component embeds cloud specific control logic. So it is mainly for the cloud related architecture of Kubernetes. It only runs controllers that are specific to that respective cloud provider. So on-premise Kubernetes clusters will not have this component. And node controller for checking the cloud provider to determine if a node has been deleted in the cloud after it stops responding. And you'll also have route controller for setting up routes in the underlying cloud infrastructure. And also same as kube controller, you'll also have something called service controller, which is for creating, updating and deleting cloud provider load balancer. So these are all the master node components in the Kubernetes architecture. Okay, so now let's see the worker node components. Okay, so in a worker node, container runtime is going to be as usual on every worker node. So the underlying software where we run our stuff is going to be the container runtime inside the worker node or whatever the VM instance in them. Okay, so we are going to use Docker, but we have other runtime options like RKTR, containerd, etc. So now one thing here is the next one is kubelet, which is the more important one. So let's see about it. Okay, so kubelet is the agent that runs on every node in the cluster. So the more number of worker nodes, on every worker node we are going to see kubelet is present inside that. So this is the agent is responsible for making sure that containers are running in a pod on a specific worker node. So, and next is the kube proxy. So it is a network proxy that runs on each node in your cluster. It maintains network rules on nodes. So then what is the use of it, right? So in short, these network rules allow network communication to your pods from network sessions inside or outside of our respective cluster. So these are the core things about Kubernetes master and then worker node components. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to understand about EKS cluster architecture in combination with Kubernetes cluster components. Okay, so as usual in EKS control plane, which is nothing but cluster control plane, so you will have the master node, same as our regular Kubernetes cluster. So we'll have the container runtime, kube API server, etc, kube scheduler, and here it is going to be kube control manager. And in addition to that, we are also going to have something called Fargate control manager, and then Fargate related scheduler also will be available as part of that. So which will schedule the Fargate pods on serverless Fargate infrastructure in AWS. So in addition to that, if you see there we have the worker nodes, and here you can say it as EKS managed node groups. So under this we are going to anyway have worker nodes only, and container runtime, kubelet, and then kube proxy are common everywhere. So now what is differing here? Okay, so means like you have the EKS cluster control plane and then EKS managed node groups, and on regular on-premise Kubernetes also we have all these things, means like the master components and then worker components. So what happens in EKS is EKS lets us focus only on our application workloads. So we don't need to worry about any of these components, either it is etc high availability or kube scheduler pod or kube API server pod or this respective entire what is present in these blue boxes is not our job. Our core focus will be how to design our applications and then how to deploy those applications into Kubernetes cluster and its node groups available in AWS. So which means, so we really don't need to worry about the high availability or the maintenance or anything about these master or worker nodes. So once we create and then create the cluster autoscaler for our EKS, our job is done. So the rest end-to-end maintenance of our all these components will be the responsibility of the AWS. So that's about the EKS speciality. So with that said, we'll move on with our next steps in our upcoming lectures. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to understand about Kubernetes fundamental core concepts, pod, ReplicaSet, deployment, and service on a very high level. So let's understand what are those actually, right? So pod is a single instance of an application. So a pod is the smallest object that you can create in Kubernetes. When you come into ReplicaSet, a ReplicaSet will maintain a stable set of replica pods running at any given time. So in short, it is often used to guarantee the availability of specified number of identical pods in a deployment. So a deployment runs multiple replicas of our application and automatically replaces any instance that fails or becomes unresponsive. So rollout and rollback changes to applications are additional features about deployment when you create it as a deployment. So deployments are well suited for stateless applications. And finally, service. So a service is an abstraction for pods, providing a stable so-called virtual IP address fronting these pods. So in simple terms, service sits in front of a pod and then acts as a load balancer. So this is a very high level introduction about these things, but in upcoming lectures, whenever we deal with each section, so we are going to have a very detailed pictographical and then visual manner what we are doing and equivalent hands-on sections. Okay, so now we'll move on and then understand what is our approach in implementing these fundamentals, right? So we are going to use both approaches, which is nothing but imperative and then declarative way of implementing the Kubernetes core concepts. Okay, so using kubectl, with kubectl commands, we are going to create pod deployment and then service imperatively. And for ReplicaSet, we really don't have a kubectl command to directly do it, so we are going to use YAML file to create them. And in declarative approach, so we are going to use YAML as our language to create the Kubernetes manifest, and then use kubectl to create pod ReplicaSet deployment and then service, and then understand and then master these concepts hand to hand using even the live template writing using YAML also. So all in all, we are going to do this in two ways, which is one is imperative way and the declarative way. And over the process, everything, right? So everything is documented in a Kubernetes, means like in a GitHub repo on a step-by-step manner. So if you go to pods with kubectl, every step and then every command, whatever you are going to execute, everything will be available for you in a step-by-step manner, so that we really don't fail anywhere or stuck anywhere when we are implementing it. Okay, so if you see services with kubectl, whatever commands you want to use, everything you are going to use. And if you see services with YAML, so you are going to have a kube manifest with all the manifests, whatever you are going to write them directly, which means like you are going to create all these things by live template writing and then implement them. So that's about the introductory section of what we are going to do as part of this course. So I'll see you in the next lecture and then start with the pods with kubectl. So until then, bye bye. Thank you. Welcome back. In this lecture, we are going to understand about the core Kubernetes concept named pod. So with Kubernetes, our core goal will be to deploy our applications which are in the form of containers on the Kubernetes worker nodes in a Kubernetes cluster. So Kubernetes does not deploy these containers directly on the worker nodes. Container is encapsulated into a Kubernetes object named pod. So a pod is a single instance of an application. So a pod is the smallest object that we can create in Kubernetes. So pods generally have one-to-one relationship with containers. So if you see here, we have one pod in worker node 1, and then we are having some amount of traffic coming to that. If our traffic keeps growing, so we are going to add new pods for scaling our application like this. And so that it means is like to scale up, we create new pods, and then to scale down, we delete the pods. So for our application, if the traffic keeps growing, we need to scale our application in the form of pods. So now, so we cannot have multiple containers of same kind in a single pod. So this is one more important thing which we need to understand. So if you have a worker node 1 and then you have a pod with Nginx serving the purpose of static content, or it is acting as a proxy. So now if your traffic keeps growing here, right? So you cannot scale your container image inside the pod. Always, whenever your traffic is growing, you need to scale the pods instead of scaling the containers inside the pod. This is the wrong way and this is the right way. So 2 Nginx containers in a single pod serving same purpose is not recommended all in all. So now if we see, we can also discuss about multi-container pods. So can we have multi-container pods? Can we have multiple containers in a single pod? Yes, but in exceptional cases. Out of 100, 99% always one pod will have one container, and the 1% cases are, we can see, now in our next slide, right? So we can have multiple containers in a single pod provided they are not of same kind. Example, in this Kubernetes cluster, in this worker node, you have a pod and you have a Nginx container serving the static content or acting as a proxy. And you have one more Nginx container or whatever the container, which is called the helper container, right? So they do the helper jobs here. So what are these helper containers? In Kubernetes terms, we call that as sidecar containers. So we can call them as data pullers, data pushers, or proxies. So as data pullers, they pull data required by the main container from some other service in the network, or they push the data by collecting the information from this Nginx main container, or they can even act as proxies, means like write static data to HTML files using helper container and read using main containers. Or moreover, if you go into more like our cloud technologies, usually the latest is like now the Istio and all these things came in. So we'll always have a sidecar container, which is nothing but the Envoy proxy. So in such cases, we use the sidecar container. But all in all, 99% cases, always pod to container is a one-to-one relationship. So now, when we are using these multi-container pods, so we have the following advantage. So the two containers can easily communicate with each other as they share the same network, and they can also share the same storage space. So multi-container pods is a rare use case, and we will try to focus on core fundamentals, which is nothing but one pod to one container, one-to-one relationship. Now, in the next lecture, we are going to focus on the Kubernetes pods demo. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. So in this lecture, we are going to look into the pods demo. So let's go ahead and then do that now. So we'll go to our GitHub repo. In Stack Simplify Kubernetes Fundamentals GitHub repo. So we are going into pods with kubectl 02 pods with kubectl. So we are going inside, and just now we have completed the step 1, which is nothing but the pods introduction. So we are moving into the pods demo now. So first thing what we need to do is whether our worker nodes are ready. So we need to say kubectl get nodes to check that. So kubectl get nodes, and our worker nodes are ready. And if you want to see them with wide option, so you can say -o and then wide. So it also provides additional information about our worker nodes internal IP and our worker nodes external IP, which is nothing but our external internet facing IP address for our worker nodes. So now moving on, so let's go to the pods. So we are going to create a pod. So to create a pod, we can use kubectl run, as we are going to do this in an imperative way, not a declarative way. So we are going to say kubectl run and our pod name, which is nothing but my first pod, and the image what you are going to download. So I have pre-built a container image, which is stack simplify /kube nginx 1.0.0, so we can use it. So it is already publicly available on my Docker Hub. So if you see here, kube nginx 1.0.0, which is the tag. So we have multiple versions here. Whenever we are moving on with replica sets, or we are going to go inside deployments and then services, we are going to use different versions to understand in different manner. But for now, we are going to use the stack simplify /kube nginx 1.0.0 tag. So let's come back here and then use that. And then we also have additional tag named generator is equal to run-pod /v1. So this is required to create pod as a pod instead of a deployment. So this is one important note here. So if you want to, you are just creating pod and then you are doing the pods demo. Why do you want your command to automatically create a deployment, which is another core concept, and then get confused with that? So that's the reason we need to use this tag. But when we move on to the very latest version, which is nothing but 1.18 version, which is very recently released, So you really don't need to even add this tag. Okay, Kubernetes has done a lot of cleanup with the kubectl run command, and we really don't need it. But I am currently using 1.16 version, so that's the reason I'm going to use this. So let's copy this command and run it here. Right, our pod got created. So we can go ahead and then list our pods using kubectl get pods. Right, and my first pod is ready and then running. So one important thing here is, for our pod, if you want to even give get PO, right? So this PO is nothing but the alias of pods. So you can give a shortcut, you can say, right? So it's the same thing. So now you have listed your pod. If you want, you can even use the -o and then wide option to see more information about your pod. So earlier you have seen only till age, but now you are seeing the IP address of your pod, which is nothing but your application, right? So your IP address of your pod is provided here, and on which node it is hosted also you can see. In this respective node it is running. So we have 118 and then 145 here, and out of which this pod, we are only running a single pod and it is currently present on 118 node. So next is what happened in the background, right? So we need to understand what happened in the background. So Kubernetes created a pod. What happens? So when we see that using the describe pod, we'll come to know. So let's go ahead and then describe our pod. So kubectl describe pod, and then pod name is the syntax. So let's go ahead and then describe our pod here, right? So we can see the events here. Successfully assigned a default my first pod to this respective node, which is nothing but the worker node. Then it pulled the image from the Docker Hub, right? And it successfully pulled the image and created the container inside the pod and started the container. So that's what happened in the background. So that is about what happened in the background. So we can see in the events portion of the describe command. So now what is this describe command? So the describe command is the very important command which helps us in troubleshooting. So if our application has been deployed and the pod is in pending state or crash loop, back off state, or in different states, you can directly go into the describe command and then verify what happened in the events. And also here also you can see additional information about the same thing. So if you see here, the name of the pod is my first pod and it has deployed to the namespace default, and in which node it has deployed it is showing in the describe pod. So you'll get end-to-end lots of information about everything. So what is my pod IP you are seeing here, and in addition to that, from where it has pulled the container, all these image ID and then information it is providing, whether it is started, ready, true, all these information you can see everything in the describe command. So it's always good to understand, means like it always means like when you have an issue, first start with the describe command and then go to the logs, kubectl logs. So we'll see that later. Okay, so now the next thing is access application. So currently we have created a pod, and this pod we will be able to access directly from our worker nodes. We can log into worker nodes and then access it currently, but how we are going to access it externally via internet, right? So that's our core thing, right? So to access it externally, we need to create a service. In our next lecture, we are going to focus on that. But for now, we created the pod. So let's go ahead and then delete the pod also. So using kubectl delete, we can delete our pod. So first you will say kubectl get pods, and we got the pod. So I'll say kubectl delete pod and my pod name, right? So I'll copy and then paste it. So my first pod, right? So my pod is getting deleted, and once it is deleted, so let me clear, and I'll say kubectl get pods, and I don't have anything in the default namespace. So that's about the pods. In our next lecture, we'll focus on creating a service and accessing this pod via internet. I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to understand about one more Kubernetes core concept named services. And in services, specifically, we are going to focus on NodePort service. So why we are introducing this concept very early during the pods demo itself? The reason is, so we have deployed a pod. Until and unless we test it and then access it, we really don't know what is happening, right? So everything, if we test, then we know what is happening. So in that line, so we are going to introduce this, which means like whatever the pod we are going to deploy on the Kubernetes cluster, we are going to expose it to the internet and then access it and then ensure that my application is running. So that gives a good feel for us, right? So let's do that now. So we can expose an application running on a set of pods in Kubernetes using different services available in Kubernetes. So those are cluster IP, NodePort, and load balancer. So cluster IP is specific to a cluster, which means like in its boundary is only a cluster, and inside the Kubernetes cluster you can access your pods with cluster IP if you have created a cluster IP service for your pod. And NodePort is nothing but using the nodes port, whatever it is exposed, using that port you will be able to access your application externally via internet. And another thing is load balancer. So this is specifically for our cloud providers like AWS and then Google and then Azure. So their load balancer service is integrated with Kubernetes, so that using load balancer service, you will be automatically able to create a AWS Elastic Load Balancer or Azure Load Balancer or Google Load Balancer automatically. Moving on with NodePort service. So to access our application outside of Kubernetes cluster, we can use the NodePort service. So it exposes the service on each worker node's IP at a static port, nothing but the node. A cluster IP service to which the NodePort service routes is automatically created whenever a NodePort service is created. And the port range for our worker nodes is going to be 30,000 to 32,767. So now let's understand the entire flow in a diagrammatical manner. So you see, you have a Kubernetes cluster with a worker node here. So and then you have deployed your pod, Nginx pod, which is nothing but your my first pod, whatever it is we have seen earlier, we have deployed it here. So now we have created a NodePort service. So what happens, right? In a NodePort service, you will have something called, every service will have its own port. So that is nothing but the cluster IP service port. So your pod port is 80 and your cluster IP service port is also 80. So the next thing is target port. So in the service, you will have the definition called port, which is 80, which is nothing but the service port, and the target port. And the target port is nothing but container port in a pod. So this is nothing but your respective pod's port. So this is pod port 80. And the next thing is worker node port. So this is nothing but whatever it starts from 30,000 to 32,767. So whenever you are creating it using the imperative way, you don't have an option to declare it the specific port. But whenever you are doing it in a declarative manner using YAML, so you can define one specific port number from this respective range. So I can say 32, 331 or something, and then you can specifically declare your port and then use it when you are using via YAML. But when you are doing with imperative way using kubectl, you really don't have, and then automatically Kubernetes assigns one dynamic port between this range. So that's about the worker node port, and then cluster IP service port, and then container port in a pod. So now the next thing is, whenever a user tries to access using worker node IP and then node port, so the traffic comes via our worker node's respective port, which is in between this range, and then it will send to the cluster IP service under that on port 80, and then from there it will send to the target port, which is nothing but the 80 port on our pod, and then our application will be accessible. So this is about the NodePort service on a very high level. So in our next lecture, we'll focus on the entire demo for this one. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to create a pod and then expose it to the internet using the NodePort service. So just now we have completed the NodePort service introduction in our step 3, and then we are moving to the step 4. So now let's understand these ports one more time, which is nothing but port, target port, and then NodePort. So port is nothing but port on which NodePort service listens in Kubernetes cluster internally. So which is nothing but your cluster IP port. And the target port is nothing but we define container port here on which our application is running. And the node port. So node port is nothing but worker node port on which we can access our application. So these things are very important whenever we are defining our YAML in a declarative way whenever we are creating a service. But even now, if we need to understand about port and then target port, because in our upcoming steps here, like we are going to understand more about this target port and then its importance, all those things. Okay, so now let's go ahead and then create the pod one more time, whatever we have created in our previous step. So let me copy this and then create our first pod now. So our pod got created. I'll say kubectl get pods and then my pod is getting created and it is running now. Good. So now we are going to expose pod as a service. So the command here is kubectl expose and then that respective pod with what is the pod name of that pod, and then the type is a NodePort service with port is 80, which is nothing but my service port is 80, and name of my service is my first service. So let's go ahead and then expose that now. It's exposed. So now if you want to see the services, kubectl get service, right? And you can see the default Kubernetes service with the cluster IP is available here. And we also got my first service with NodePort of type NodePort, and it also has the cluster IP, and the cluster IP port is 80 and the node port is 31084. And you also have the alias, which is nothing but kubectl get svc. Okay, so how for pods PO, the alias for services is svc. Even with svc we get the same output. So the 80 here, whatever you are seeing is the cluster IP service port, and 31084 is our respective node port, worker node port. So now the next thing is how to access the application, right? So you also need to get your worker node public IP to access it. So let's get that using kubectl get nodes -o wide. So you will get the public IP of your cluster here, so which is nothing but this one, and take it and then access it. And what is the port? 31084. And our application is accessible now. Welcome to Stack Simplify Kubernetes fundamental demo, and our application version is v1. So now let's go back here and then see one thing. Okay, so get pods -o wide, right? So this is running on 145 server, right? And then you accessed the external IP of 118 server, which is nothing but the another server, but still it is accessible. The reason is the service is across the worker nodes. Whatever the service you create, it will be across the worker nodes. We'll see more in our replica sets and then deployments and then services. But what I'm trying to say is both nodes will have the same 31084 assigned, and via any of the nodes we will be able to access our service. Just now we accessed it with 173. We can even access with 213 and then we'll get the same response. 31084, right? It's the same thing. So service will get created across the worker nodes. So that's about it. So now one thing we need to understand here is target port. So if you see here in this expose command, we didn't define the target port. So which means what it means is whatever the service port we have assigned, the system feels that the target port, which is nothing but the container port, is also going to be 80 only. So it will take it by default the same value. Now if you try to change this to 81, so obviously what happens, you can see now, right? So your port is 81 and then you are not defining any target port, so which is different, right? Our container port is 80 and then you are trying to define your service port as 81. So let's see what happens, right? So let me copy it and come back and then paste it, right? Okay, service got created, but will it be accessible for us? So get svc, right? And this is the service, and we got 31100. If we access, it is not going to work because our pod is not running on port 81. So in these cases, which means like your service want to run on different port and your backend is on different port, so you need to always define your target port parameter also. For now, let's access this and see what happens, right? So let me come here, and the port is 31100, right? It failed. So in the same way, so now let's go here and then access it with, define it with target port 80 and then create a service. So we'll create this service as service 3. I have done service 2 one more time. I will correct it. So this is service 3, right? So now get ports. Here you have defined your target port, which is nothing but your container port as 80, right? So now we will say svc, and its port is 31961. Ideally it should be accessible now for us. Okay, so 31961 is the port. So let's access it. So now we have got our application. If you want, we can even take the new tab and then access it, and then accessible. So that's about the importance of target port. So if we want to use our service port, a different one other than the default port what our container is listening on, so then you also need to define your target port in your kubectl expose command. So that's about it. In our next lecture, we'll focus on interact with pod and then other steps. I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to interact with our pod. So we can get the pod logs and then view the pod logs or stream our pod logs, and even we can connect to our container inside the pod. All those things we are going to do now. So let's start with the pods now. So we can dump our pod logs using kubectl logs and our pod name. So and even we can stream the pod logs using -f. So let's see both of these things now. So we already have our my first pod here. So let me paste it, and kubectl logs my first pod, and it dumped all the pod logs here, which is nothing but we are going to access the root context in our Nginx application, and then it is serving the content. So now let me do kubectl logs -f. So to stream the logs, right? My first pod. So now we have the logs here. So I am just entering, and then I'll try to access something, and then our logs should come here. So let me go here and then say enter, and we got it, right? So this is one more, and I will say /index.html and then access it, right? So we got it. We can see it, right? So /index.html. So we can even stream our logs using -f command. So let me type Ctrl+C and go back here, and that's about the pod logs. In addition to that, you can refer this link for kubectl cheat sheet, where you will have lots of commands for your understanding, mainly kubectl logs and then logs related options, right? So if you see here kubectl logs, right? So there will be multiple options available here to interact with our pods. So with the -l or -f or with -c, which means if we have multiple containers and then specific container logs if we want, then we can even provide the -c and the container name to get that respective container logs. So all these things we can see, and then all these are important commands for us when we are troubleshooting our issues on the application. Whenever we deploy applications and there are issues to troubleshoot, all these will be very helpful for us. So now the next thing is to go and then connect to our pod. So let's do that using kubectl exec command. Okay, so using this command kubectl exec -it and then pod name and then -- ours is a bash shell. So we will go and then access it, which means my container is using bash. So let's access it, and now I will be in my container. So it is in my first pod. So you can see here I am in my first pod in my container. So I can say ls and then I can type the commands. I can go to usr share nginx html and then I can say I'll have my index.html here. I can say cat index.html. You can see the same content whatever you have seen on the browser right here. Welcome to Stack Simplify fundamentals demo and then application v1, the same thing you are seeing. So you from again, if you want to exit your container, say exit and then you are back to my MacBook Pro, which is your kubectl area. So now that's about connecting to the containers. And you can even, instead of connecting and then going inside and running it, so you can directly run outside itself, which means from your kubectl itself you can add the command and then run it. So kubectl exec-it and your pod name, and the command you want to run inside your respective container is env or ls or cat. All these things directly you can run here. So let's run it and then see. It will paste the environmental variables of our respective container. So you can see Kubernetes service port and then Kubernetes port, all these information from our container we are getting. In the same way you can do ls or you can do cat. Again we'll do index.html cat for us. So let's do that now. So we got the output Kubernetes fundamentals demo. And the next step is to get the YAML output of a pod and a service. So just to see our YAML definition, so we can even use kubectl get pod and the pod name and then -o YAML. Instead of -o void what we are doing, now you can say YAML, so that we'll get the YAML definition of our respective pod. So all this it provides in the YAML format. In the same way you can do the same for your service. So you can copy and then paste it here. Okay, so that's all. So now this completes the interacting with pod and then getting the information about our pod and all those things. So now you can see here in our YAML definition for service, one important thing is, see the node port is 31084 and the port is 80 and the target port is 80. So now you can even try for service 3 whatever we have created, right? So node port is 31961 and port is 81, which is nothing but your service port is 81 and your target port, which is your container port, is 80. So that's about the information about the ports in your service. You can see in the YAML definition whatever it has created. So now in our next lecture we'll move on with the cleaning up whatever we have created. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this step, whatever the objects we have created, we are going to delete them. So using kubectl delete, we can delete them, and using kubectl get all, we can get all the objects present in the default namespace, right? So I'll say kubectl get all, so which will provide all the objects present in the default namespace. So which is nothing but I have my pod, my first pod, and I also have the service, my first service 2, and then my first service 3, right? So now let's go ahead and then delete one after the other. Kubectl delete and then pod, and then pod name is my first pod. So I can type it and my pod got deleted. In the same way, we can go ahead and then delete service is svc and my first service and 2 and then 3. So now if you say kubectl get all, you will only see cluster IP service of Kubernetes. Rest all got deleted. So that's about the cleanup. So I'll see you in the next lecture with the replica sets. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to understand about one more Kubernetes concept, replica sets. So replica sets help us in achieving high availability and then reliability for our applications hosted on Kubernetes. In addition to that, it helps us to seamlessly scale our applications, and in combination with services and replica sets, we will also be able to achieve effective load balancing in Kubernetes. Finally, labels and selectors. So using labels and selectors, we will be able to tie all the replica sets, services, and then pods together. With that said, a replica set's purpose is to maintain a stable set of replica pods running at any given point of time. So if our application crashes and any pod dies, example, if you see here in a worker node, we have 2 pods and then one pod got died. So if that is the case, replica set will recreate the pod immediately to ensure the configured number of pods running at any given point of time. So we configure the number of replicas in our replica set. So if we say that always it need to have 2 replicas, then replica set will ensure that it is running with 2 pods at any point of time. So in this way, reliability and then high availability for all applications are achieved. The next thing is load balancing. So to avoid overloading of traffic to single pod, we can use load balancing. So Kubernetes provides pod load balancing out of the box using services for the pods which are part of the replica sets. So labels and selectors are the key items which ties all these things together: pods, replica sets, and services. So we will know in detail about these labels and selectors when we are writing the YAML manifest in our upcoming lectures. So if you consider a Kubernetes cluster with 2 worker nodes, if you see the replica set is spanned across 2 worker nodes, and we have 2 pods in one worker node and then 2 pods in another worker node. And to access the applications hosted on these pods and then allow the effective load balancing, so we will have the services in middle. So services will distribute the traffic to this respective replica set and the pods present inside that. So with that said, in combination with replica set and services, we can achieve effective load balancing in Kubernetes. And the next thing is scaling. So when load becomes too much for our number of existing pods, Kubernetes enables us to easily scale up our applications, adding additional pods as needed. So this is going to be seamless and super quick. So let's consider a Kubernetes cluster with 2 worker nodes and you have 1 pod in each one, and then a service is load balancing the traffic to them, and all of a sudden you have a spike in your traffic. If that is the case, to scale you have multiple options in Kubernetes. First thing is go ahead and then update your replica sets, number of replicas, and to the desired number how much we want, and then apply that. Or you can use kubectl scale to do that, or you can even enable the horizontal pod autoscaler to autoscale the pods to achieve the or to support the amount of traffic spike at that point of time. Now let's go ahead and then implement the Kubernetes replica set demo. I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are looking into the replica sets demo. So let's check into it. Okay. So we are in our Kubernetes fundamental 03 replica sets with kubectl section, and we completed the step 1 introduction just now, and then we are moving into the creating replica sets. So one important thing about replica set is we really don't have an imperative command to create a replica set. So we need to definitely define our YAML manifest. Okay. So here we are going to only look into whatever is required inside that in this YAML manifest, and then more than that, other things we are going to discuss when we are going to write the YAML once we learn the YAML fundamentals and then all those things. So for us, if you see here, API version is /apps v1 and the kind is replica set which we are going to create. Means like the object which we are going to create in Kubernetes is replica set. And the replica set name is my hello world rs. So that's the replica set name. And in addition to that, number of replicas means like number of pods it need to get created is 3 pods. Okay. Forget about labels and these selectors and these labels, all these things. Let's forget about it for now. We'll see when we are writing YAML definitions. Okay. So now replicas is 3 replicas, and the next is container spec, right? So name of the container is my hello world app, and my image is stack simplify /kube hello world 1.0.0. So this is the application. So let's go ahead and then create it using kubectl create, and then file name is replicaset-demo.yml. So let's go ahead and then create it now. So if you fork this respective directory, which is nothing but this Kubernetes fundamentals, fork and then download, or download this to your local repo, and you need to just go into 03 replica sets with kubectl, and you will find this replicaset demo.yml file here, right? So I'll go into that now. So if you see here in Kubernetes fundamentals, I'm going to 03 replica sets, and I can find the file here. So I'm saying kubectl create -f and replicasets demo.yml. My replica set is getting created. So now the next thing is to list the replica set, right? So you can say kubectl get replica set, and it will be listed my hello world rs. You can see here desired number of replicas are 3, whatever we have configured here, and current is 3, and then ready is 3. Okay, so now the alias for replica sets is kubectl get rs. Even you can use rs if you want to, right? So and the next thing is to describe the replica set, kubectl describe, and rs is alias of replica set, and my replica set name is my hello world rs. So let's describe the replica set, right? So now if you see in this replica set, so let's go here, and we can see all the information. Okay, so successfully created the replica set controller and it created 3 pods here. Okay, so for all the pods it doesn't have any issue in creating it. So now let's list the pods. So kubectl get pods. So now we have 3 pods, means like 3 replicas got created, my hello world rs and some dynamic name, right? So in the same way we can even list the pods with wide option, so that we know on which nodes these pods were scheduled. So on 118 we have 1 pod scheduled, and on 145 we have 2 pods scheduled. So in addition to that, if you want to verify the owner of the pod, right, so we can give the kubectl get pods, and then pod name, and then -o, and then YAML. Get the YAML output, and inside that when you refer the owner references, you will get those details. So kubectl get pods, and then any one of the pod name. So we'll get the replica set as the owner. Right? So if you go up, and we can see here, right? So owner references, we can see the name tag here, which is nothing but my hello world rs, which is nothing but the replica set. So in simple terms, to whom this pod belongs to is nothing but this pod belongs to that respective replica set. So that you can find using owner references. So now in our next step, we'll focus on exposing this as a replica set as a service. I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to expose replica set as a service, so that we will be able to access the application present in replica set pods via browser. So let's go ahead and then do that now. So we are going to say kubectl expose replica set, which is nothing but rs, and the rs name, replica set name, and the type is going to be NodePort, and the rest all is going to be same. Port is the service port, which is cluster IP port, and the target port is nothing but the 8080, which is nothing but my application port, whatever it is running, my container port, kube hello world container port is 8080, and the name of the service is going to be my hello world rs service. So let's go ahead and then do this now. Right, so it's completed. So now let's go ahead and then get the service, right, and you have it as 30505, and get nodes -o void to get the public IP, and the public IP is this one, external IP, and the port is 30505, right? So let's go here and 30505/hello, and we got this. Okay, so let me make it bigger, and now if you want to refresh, and you can take the same URL and in new tab one more time access it, you see one more value here. Okay, and in one more time, and you can do one more time. So like this you can access, and then it will keep load balancing. So if you see here, it is D7HVK, here it is Z and BGW. So to which container it is going, that respective container's ID it is going to throw it here on the browser. So let's see what does that mean. Okay, so kubectl get pods. So you see it, right? The request went to Z and BGW container. Okay, so that's what it is showing here. And another request went to D7HVK. So and then you have this here. So like that, I have written a Spring Boot code, means like Java code, in my container, and then packaged it so that now whatever to which container it goes, that respective container ID you are going to see it here, just for fun. Okay, so nothing much inside that, but you need to access your application in this manner. Okay, so node1 public IP colon NodePort whatever we have got, and then /hello. The context of this application is /hello because it is a hello world application. In our next step, what we are going to do is we are going to test the replica set's reliability or high availability. So what does this mean? So whenever a pod is accidentally terminated due to some application issue, replica set should auto create that pod to maintain the desired number of replicas. So that's what is replica set's reliability or high availability concept. So you have here 3 pods running, right? So and if you go ahead and then delete one pod, kubectl delete pod, and then delete one pod. So you are trying to simulate the accidental deletion. Okay, so automatically it should start creating one more pod. Replica set will create the pod immediately. So there is some connectivity issue, but we'll try one more time. Okay, so now the pod got deleted. So let's test this with kubectl get pods. So once we have deleted the pod, and now you see that the old 2 pods whatever are there is age of 27 minutes, but whatever you have deleted, and then replica set automatically created a new pod which is of 95 seconds. If we want, we can delete one more couple of pods one more time. Okay, kubectl delete pod, and then we'll also delete our D7HVK pod. Okay, so and then in that place replica set should create one more pod. So let's see that now. kubectl get pods. Now you can see that, so D7HVK is gone, and then you have got in that place 27.4 new pod, 16 seconds its age. So you can see the first one pod is from 28 minutes it is running, the other is from 2 minutes, and this is from 16 seconds. So what here replica set is doing is it is automatically creating the pods to ensure that the number of replicas whatever we have configured here, right? So it is trying to ensure that the number of replicas are going to be 3 always. So that's about the replica set reliability or high availability concept. So the next concept is replica set's scalability feature. So we can simply scale our replica set just by updating our spec here, right? So we can go into our spec. So let me go here, and this is my replica set, right? So and then I will say here 6 replicas, right? And then save it, and then apply the change, which is nothing but kubectl replace and the same file. Okay, let me say clear and paste kubectl replace -f and the replica set demo.yml, and let's see what happens. So now our replica set got replaced. kubectl get rs, the replica set we are going to see. Now you see the desired replicas are going to be 6, current is 6, and then ready is 6. So I'll say get pods, and then you should see 6 pods up and running here now, right? So that's about it. So from last 22 seconds we have 3 pods came up online automatically. So in this way you will be able to scale your replica set quickly by updating the number of replicas in your ReplicaSet demo.yml. So that's about it. And now the next thing is to delete the replica set in the service. So we are trying to clean up the stuff. Okay, so let's go ahead and then it will get rs. So we'll get the replica set name kubectl delete rs, and we are going to say my hello world rs. The same way get svc, which is nothing but kubectl get services, and kubectl delete svc my hello world service. Once this is completed, you can say kubectl get all to see that whatever is present in your default namespace where you have worked. Other than Kubernetes default cluster IP stuff, no other thing is available. So this completes the replica set end-to-end whatever we have learned using imperative way. Just we have used only the YAML file for us because imperatively you cannot create a replica set object. Now one thing important here is like one pending concept is present in replica set, which is labels and selectors. So this is going to be a common concept for multiple Kubernetes concepts, okay, like pods, replica sets, deployments, and then services. Everywhere we are going to use labels and selectors. So we are going to cover it when we are writing equivalent YAML files there, so that we will understand in detail. With that said, in our next lecture, we'll start working on the deployment concept of Kubernetes. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. In this lecture, we are going to understand about one more Kubernetes core concept called deployments. So we have already seen a Kubernetes cluster with 2 worker nodes and 2 pods in each worker node from a replica set. So now deployment is going to be a superset of replica set, which means replica set can provide few features, and when we call deployment as a superset, it can provide many features for us. Okay, so in addition to what replica set provides. So that's about the deployment advantage we have, and there is no difference in accessing the applications hosted via replica set or deployment. So all it is going to be using the service concept in Kubernetes. So now let's go ahead and then see what are the deployment features available for us, or what it provides for us or for our applications hosted on Kubernetes. So we can create a deployment to roll out a replica set. By default, whenever we create a deployment, a replica set is rolled out. And updating the deployment. So whenever we want to change our application version, update our application version, we can do the updation of the deployment. When we do this, automatically our version, whatever we are going to update, it is going to be recorded. So now using that, we can easily roll back to our respective older deployment, whatever we want, because it is maintaining the versions. Or if you have updated from v1 to v2, v2 to v3, and then v3 to v4, and now again if you want to go back to v2, yes, you will be able to go, because it maintains the versions and then version history. So now we will be also able to scale our deployments. So how we have done the scaling in replica sets, in the same way in deployment also we'll have a tag of replicas where we can add the number of replicas, we can add it, or we can use kubectl scale to scale our deployment. And we can even pause and resume a deployment. So in deployment, the core thing here is like whenever you apply a change to your deployment, immediately it will be applied to your pods. So that is the thing. So if you want to make multiple changes, then you really don't want the pods to be recreated or terminated and recreated every second for every change. So you have 10 changes to make to your deployment, then pause the deployment and make all the changes, and then resume the deployment, so that all those changes will be applied to your deployment at a time. So like this, there are multiple things we can take an advantage using the deployment. So whenever you are doing the deployment, you can even get the rollout status or deployment status. And there will be something called cleanup policy. Cleanup policy is nothing but, so whenever we do the updation of our deployments, it maintains the rollout version history, and by default it maintains last 10 versions of our application. So we can go to that respective version using that, or we will be able to add more number of versions by adding additional tag in our YAML manifest under the spec of the deployment. We'll see that in the later cases if we want to. So, and next thing is canary deployments. So if we want to add a new version of our application in the live production traffic, and the traffic should distribute with old version and the new version, still we will be able to do it using canary deployments. So all these things are available for us with deployment. So let's go ahead and then create a simple deployment object and then expose it as a service and then access it via browser and then test it once. After that, again we'll move on to updating the deployment, rollbacking the deployment, or pausing and resuming. All those things we are going to see step by step now. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to do the deployments demo. So we'll go to 04 deployments with kubectl. So let me go inside. And inside that 0401 will be creating our deployment, scaling our deployment, and exposing it as a service. So all those things we are going to do it now, right? So step 01, introduction to deployments, we have just now completed. So we are going to move on to creating a deployment, right? So to create a deployment, we are going to use kubectl create deployment and the deployment name, whatever we are going to put, and our container image. So we are going to use the kube nginx image, and if you see here, this is the Docker image location, and we have 1.0.0 to 4.0.0. So if we have 4 versions of our nginx application which we are going to leverage and then test end-to-end all the deployment features about updating the deployment, rolling back the deployment, or pausing and then resuming the deployments. In addition to that, rolling back the deployment to specific version or rolling back the deployment to older version or previous version. All these things we are going to test it. So that's the reason we have 4 versions of our nginx application present here. So let's go back. So let's create the deployment now. So we are going to copy this and go here and paste it. So our deployment got created. So we'll say kubectl get deployments, right? So our first deployment got deployed. Even we can use the alias name deploy. So these aliases will help us in when we are in hurry. We really don't need to completely provide the deployments, or just give deploy and then it provides the output. In the same way for services it is SV, and then for pods PO. So it's always good to learn these aliases. For replica sets it is going to be RS, so like that. So now kubectl describe deployment and the deployment name. So my first deployment, right? So this is the deployment. Scaled up replica set by my first deployment, whatever the replica set name it is providing. So if you say kubectl get RS, so we have seen that creating a deployment will create the replica set. So it has created one. So we can see it, and it has one pod under it. So let me clear this and say kubectl get pods. So we have one pod created as part of this deployment. So now the next thing is to scale our deployment. So using kubectl scale, we will be able to scale our deployment. So let's do that now. Kubectl scale, and the number of replicas, I want it from 1 to 20, right? And my deployment name, right? My first deployment. So you can use deployment space my first deployment, or even we can use this way. Anything is fine. So now it is going to scale. So let's see kubectl get deploy and also kubectl get So we have 20 and then already 16 is available now. They are coming up. So one more time if we check, so mostly 20 should be available. So you can even say kubectl get pods and you see all 20 out of 20 are running. So one more thing here is kubectl get replica sets. And if you see in replica sets, so we got the output that 20 out of 20 are up and running, all the pods. So now the next thing is like we can scale down our deployment using replicas to 10. So let's go back here and instead of 20, let's bring down our things to 10 and automatically our pods will get terminated now, right? So out of 20, 10 pods will get terminated and then we will end up with only 10 pods. That's good. So now the next thing is expose deployment as a service. Again, we are going to use the same NodePort service concept what we have used for our pod earlier. The same we are going to use it. So instead of pod, we are going to use it as deployment. kubectl expose deployment and deployment name, and the type is going to be NodePort, and my service port is going to be 80, and the target port, my container port, is going to be 80, and the name of the service is my first deployment service. So let's go ahead and then create this now, right? So let the service get created and now kubectl get svc, and my service is got created and its port is node port is 32169. So I'll say kubectl get nodes -o and then void. So now I got the public IP, so I can use any one of them out of 2 and then 32169. So let's go ahead and then access it now, right? So 32169. So now our application v1 version is up and running, and then we are able to access it, means like a deployment exposed as a service for us, right? So let me go back here, and that completes the simple creation of a deployment and then testing of scaling the deployment and also exposing the deployment as a service. So everything we have done using imperative commands using kubectl, right? So in our next lecture, we'll focus on updating the deployment. So until then, bye bye. Thank you. Welcome back. In this lecture, we are going to work on updating our deployments. So we are going to go into 0402 update deployment. And if you see here, we can do the update deployment using either set image or edit deployment options. So in step 1, we'll use set image, and in step 2, we are going to use the edit deployment. So and then there will be multiple things to understand and then multiple observations we need to make when we are doing this. So that will be in this model, we will get a lot of knowledge on what we are doing. So let's go up, and then so for the update deployment using set image, right? So one thing we need to do is like we need to get the container name correctly. So first thing is, if let's see the update deployment command. So kubectl set image and then deployment and the deployment name, and container name is equal to container image. So here we need to have the container name. So to get this container name, we can get that container name using this command kubectl get deployment name -o YAML, and where we can find it is spec.container name. There we can find it. So let's find our container name. So if we go up, you can see that spec.containers.name, and then you can find kubectl. So that's our container name. So in kubectl set image deployment name, and then container name is kubectl is equal to my new container image, which is nothing but stack simplify / kubectl : 2.0.0. So earlier we have used 1.0.0. So that's the reason our application is coming as application v1. So now if we are going to update it to 2.0.0. So let's go ahead and then do that now. So kubectl set image and then this one, and then we said that -- record true for our versioning, rollout versioning to be enabled. Copy and come here and paste it, right? So now our deployment got updated. Immediately we can see the rollout status here. So waiting for the deployment, and out of 9 of 10 updated, and finally 10th one also updated. So using rollout status, you can see how the rollout is going to happen. Now if you see the kubectl get pods, then ideally you see that all the pods got recreated, which means its age is only 23 seconds. Just now it got created. So with the new image, right? So now you can even see kubectl get deploy, right? So to see that all are up and running, up to date, and then available is 10. So now describe the deployment. So by describing the deployment, what we are going to understand, we can verify the events and understand that Kubernetes by default do rolling update for new application releases. So what is the rolling update, and then why we do rolling update by default? So when the Kubernetes does the rolling update, what happens is like the downtime of our application is going to be 0, right? So one after the other it is going to update our pods. And there is one more strategy in this update deployment. There is one more strategy is, in addition to rolling, there will be something called recreate. So if it recreates, which means like it will delete all the pods and then recreate at a time. So at that time you can expect the downtime for your application. By default it is going to be rolling update, so we really don't need to define anything even in our deployment spec itself whenever we are writing the YAML manifest. But there will be some cases like MySQL containers or these things wherein you want to recreate the stuff. So in those cases you can use the recreate strategy. But in general applications, whatever you use, 99.99% will be using the rolling update. So that's the reason Kubernetes by default defaulted it. Okay, so let's go here and then describe our deployment. Kubectl describe deployment and my deployment name, right? So let's see the events here once it comes, right? So you can see it here. So it has done a rolling update one after the other. Okay, scaled up ReplicaSet, and then it started updating one after the other, and then it already completed all the things. Okay, so one important thing we need to notice here is the ReplicaSet. So whenever we have done the update, it is going to create a new ReplicaSet. So the old ReplicaSet becomes 0 and the new ReplicaSet. So 26 minutes back we created the first deployment in our previous section. At that time this ReplicaSet it created. Means like with this ReplicaSet we have the old version 1.0.0. and it created a new ReplicaSet with 2.0.0 of our application. So this is one more observation which we need to know. And one more thing is get pods. Okay, pod template hash label. So this also you can compare and understand that it's a different one. So let's see here our pod and then template. So pod template hash label, you can see it here. It is pointing to our second ReplicaSet, whatever it got created. So recently, which is 2 minutes back. Okay, so that's about it. And verify your rollout history of a deployment. So we have the rollout history, so we can switch back to older versions using revision history available to us in our next section. So 0403 we are going to do the rollbacks. So at that time this will be helpful, but now we are going to just see the rollout history of our my first deployment application, right? Kubectl rollout history, deployment, and then deployment name. So it says that the version is 2.0.0 and this is the second one. So we have recorded it, so it is true. So now the last thing is access your application. So already I have it in our browser, but if you want you can go and then go to kubectl get svc and then get the node port here 32169 and get nodes -o wide to get your external IP and then access it. I already have it here 32169. So if I refresh it, so now it is V1, it should become V2. See, now my application version is V2 and the background also got changed to sky blue color. So that's about it. So now our successful deployment has been happened, means like we updated our deployment using the set image option without any issues, and all these observations we have done. So in our next lecture we'll focus on doing it using kubectl edit deployment. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this step, we are going to update our application from v2 to v3 using the kubectl edit deployment option. So this is very important option, and then this is the option we are going to use in real time most of the time whenever running deployments we have. So kubectl edit deployment name, and then we'll go inside the deployment spec and then update it. So that's the reason. So just look into it. You see it here, kubectl edit deployment and then space my first deployment, means like deployment name or slash, whatever it is. Okay. So, and then you are going to go to containers spec.containers.image and change your image version from 2.0.0 to 3.0.0. So let's go ahead and then do that now. So whenever you are doing it, you can even say that if you want to save the version history, you can say that -- record is equal to true. So let's go here, and so I can even say kubectl edit deployment my first deployment, and it is nothing but -- record is equal to true, right? And I'm going to go at the end, which is nothing but escape shift G, and I'll go up, and if you see, this is the spec.containers.image. So I am going to change from 2 to 3 here, 3.0.0, and I'm going to save it, escape:\wq, right? So now deployment got edited, right? So if you want, you can see the rollout history one more time. Okay, so maybe I am delayed, so it might have already got completed. Okay, so it already rolled out. So if you see the pods, again all the pods will be terminated and then recreated. See, all these are 15 seconds only, started just 15 seconds before or 20 seconds before. So that's a good thing. So now if you see, one more observation here is, so one more time you have edited one more ReplicaSet, means like this is one more deployment. So your one more ReplicaSet you will be able to see for your third version. So let's go ahead and then see that now. kubectl get rs, right? And kubectl get pods. So you can verify the hashtag here, right? So which is nothing but, this is the one current live one, which is nothing but 3.0.0 version and 774b, and for our pods also you can see 774b as the hash label, right? So that's about it. So now the next thing is rollout history. So let's see the rollout history of our thing, and it should be version 3, right? So this is the one we have done in version 3, and then that is what we are seeing it now. So finally, whenever we access the application, right, so we should see version 3. Currently it is v2 here, and if you want I can make it bigger, yeah, and if I refresh it should be v3. See, right? So now the application version is v3. So this completes our 2 options, whatever we have available using the imperative way to update our deployments, we have completed. So in our next lecture we are going to focus on rollback deployments. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture we are going to learn about rolling back a deployment. So we are going to go into 0403, and we can do this in 2 ways. One is roll back to the exact previous version, whatever we have just now updated, or we can go to the specific version of the rollback. So we can do that in both ways. So in step 1 we are going to roll back to a previous version, and in step 2 we are going to do in a specific version. So let's start with understanding, means like let's get the rollout history first, and then after that we'll go ahead and then see what we are going to do. So first thing is kubectl rollout history, right? kubectl rollout history and deployment and my first deployment. So we should have the 3 releases. One is the default version, whatever we have deployed, and then we have upgraded it using set image, which is 2.0.0, and later using edit deployment we went into 3.0.0. So if we want to see specific version what changes happened, we can even see that. So let's go here, and in rollout history provide the revision numbers. So even you can say like this, okay, -- revision is equal to 1. So it will provide in revision 1 what happened. So we need to observe the image tag or annotations present there. So in this respective revision 1, directly it is a first deployment, so we will have only image, and in this image you can see 1.0.0. In the same way, for revision 2, it is going to be image tag is 2.0.0, and the annotation, if you see what is the change cause, in this annotation you can see kubernetes.io and then change cause, and using kubectl set image you have changed it to 2.0.0. So like this you can see everything clearly. So now let's see revision 3. So there also you will see the annotation and the change cause, and using kubectl edit deployment you have changed the image version from 2.0.0 to 3.0.0. So that's what is the verify changes in each version. Okay, so now roll back to previous version. So let's go ahead and then roll back. So to roll back we just need to say kubectl rollout undo the deployment whatever we have done. So kubectl rollout undo deployment, and my deployment name is my first deployment. We can even copy paste, or we can even do this way. So let's execute one more time. Okay, so the changes got deployed. So now, which means like from v3 it should go to v2 version. And so let's see the rollout history one more time, right? So rollout history and remove the revision so that we'll see all the history. So we should have a rollout history 4 now, right? So why? Because now we have changed from 3 to 4, okay, and the image version from 3 to 2, which means here earlier you have the revision version 2, you have undo, means like you went to that version, so that's the reason now you got the 4 with 2.0.0. So now let's come back here. So if we roll back, it will go back to revision 2 and its number increases to revision 4. So our revision 2 number got revision 4 now, right? So now if you want, you can cross check your deployments and then replica sets, everything we can check now. So kubectl get rs, right? And it should be using the deployment whatever is used earlier for v2 version, okay, replica set, and get pods all should be deleted and then recreated now. So within last 76 seconds only, so all these got recreated. In the same way, if you want, we can access the application and then we should see v2 version of our application, because that is what we have rolled back now. So let's go back here, and currently it is v3, and then we roll back it to older version which is v2, and it should see v2. So that's the story here. So now in our next step we need to move on with the roll back to specific version. So let's do that now. So as usual, you can see your rollout history, and then we have seen just now that is nothing but 4 is the current version, right, with the 2.0.0 as the image. So now I want to roll back to specific version, and my specific version is going to be version 3, which is nothing but where I have the 3.0.0 application v3 version I am having here in this revision 3. So I'm going to say kubectl rollout undo deployment, my first deployment, and then I'm going to give the revision number here, which is nothing but to specific revision, and my revision number I am saying is this one 3, so which has the image 3.0.0. So I will say this, right, and once the changes are done, immediately we are going to see it roll back to that version. So I'm going to first check the pods, okay, and then it is deleting and then recreating it, and we will go ahead and then get the rollout history, right? So we should 3 should go away, and then we should get the same thing as 5, and we got it, right? So that's the thing. So now we can access the application and we should have the v3 version of the application because we roll back to that version. Okay, you can see that. So that's about the 0403 rollback deployments. One last thing in this is like if you want to restart your applications in a rolling restart fashion, means like all the pods need to be restarted due to some memory issues or some whatever you have, and if you want to restart your application, so you can do a kubectl rolling restart and in your deployment name, right, deployment space deployment name or deployment / my first deployment, and it will do the restart. So once the restart is done, you can say kubectl get pods and the restart should be happening now. See, so now if you see here, all restarted. 8 seconds is the age, you can see it, right, 13 seconds. So just now all these things got recreated immediately. Okay, so that's about the rollback deployment. So in our next lecture, we'll focus on pause and resume deployments. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to learn the pause and resume deployment options in our Kubernetes deployments. So let's go inside that 0404 pause and then resume deployments, right? So why do we need pausing and then resuming deployments? So if we want to make multiple changes to our deployments, we can pause the deployment, make all changes to our deployment and then resume it. So if you don't do so, as soon as you keep applying the changes to your deployment, live deployment, then automatically the changes gets deployed and then pods get terminated and then recreated. Okay, so what we are going to do is we are going to make two changes. One is we are going to make our application version from v3 to v4 as part of this pause and resume deployments, and one more change also we are going to apply about applying the CPU limits for our application. So we are going to do all those things. Okay, so before that, check current state of your deployment and then application, right? So if you see kubectl rollout history deployment, my first deployment, and then see our application current rollout versions whatever we have here, right? So we are at 6 with the kubectl edit deployment here, right? So we are at 6 now, which means, and also verify your number of replica sets, how many you have currently, right? So mostly you should have 4 replica sets here, right? So now if we create one more version, one more replica set should get created. Okay, make a note of the number of replica sets present here. We have currently 4 replica sets present, and our rolling versions also we are seeing till 6 we are here. And one more thing is access your application and see the application version. So now I am accessing it, and if you see, we are in the v3 version of our application. So let's go inside and then pause deployment and make these 2 changes. Okay, so now what I'm going to do is kubectl rollout pause, means like I'm going to pause our respective my first deployment. So let's go ahead and then do that now. Kubectl rollout pause deployment and my first deployment, right? So once we have paused our deployment, so we can make whatever the changes we want to. So we are going to update our application from v3 to v4 using 4.0.0. Earlier, whenever you have done this set image command, automatically changes happened and then all the pods got recreated, all those things. Okay, so but now whenever you do this, nothing should happen. Okay, so as our deployment got passed, whatever you do on the live deployment object, nothing should happen. So everything should be as is. So if you go ahead and then see the rollout history, okay, so we should see the same thing, which is nothing but it is only at the 6th level, right? So no rollout history because it is in the deployment pause mode. If you see the replica sets, you should have the same count of replica sets whatever you have seen earlier, which is 4 replica sets, right? So now if you resume the deployment, so then automatically changes will happen. Before that, we will also make one more change saying that kubectl set resources for my first deployment with for the container kube nginx, and I am saying how much memory and then how much this one I am going to allocate. I am writing it here. So maybe I am using a simple cluster here. So this might be a bigger number, which is nothing but 512 mi and all those things. So I will say okay, 30 MI, okay, 30 MB or even less. Okay, so I'm not even putting anything, right? So and then I'm going to put 20, right? 20 M CPU. Okay, so instead of 200 M CPU, I'm just giving 20 M CPU, right? So and then make this change, right? So why? Because I am using a T3 medium cluster. So ideally if I give this much, then I am already using 10 pods, so then it is going to create a lot of problem for us. Okay, so this error you can ignore, so it's a timeout error. Okay, the change got applied. Okay, so now if you go ahead and then see your rollout history, still nothing should happen. We have made 2 changes, but nothing should happen because still we didn't resume our deployment, right? So and if you see the application version also, it will be only v3 only. Okay, so now let's go ahead and then resume our application deployment. So kubectl rollout resume and then deployment / my first deployment. So let me do that. So as soon as we do this and then see the rollout history, then you should see the 7th version coming in. You see the kubectl get pods and they should get created, right? And then few are terminating and then few are creating. So all these things happens now. Okay, and we can go ahead and then access our application and see what happens. Okay, so let me go to my application and then access it once all pods are ready. And also let's cross check our replica sets count. Get RS, right? Earlier it is 4 replica sets and now as it is 4.0.0 version, we should have 5 replica sets. Okay, 1, 2, 3, 4, 5. That's good. So now let's go ahead and then access our application. We should see the v4 version of our application. See, now we have the v4 version. So we have successfully tested in deployments the following things: creating a deployment, scaling the deployments, exposing the deployment as a NodePort service, and updating the deployments with 2 options available for us, which is set image and then edit deployment. And also we have rollback the deployments using to previous version and to specific version. And in addition to that, we have also tested the pause and then resume deployment. So this completes the deployment section using the imperative commands. So let's go ahead and then do the cleanup of whatever we have created, right? So kubectl get deployments and then delete the deployment, right? Delete deploy and my first deployment got deleted, right? In the same way, delete svc, right? So before that, we'll get the name of the service, get svc, and then delete service my first deployment service, right? So now if you see kubectl get all from our default namespace other than cluster IP of Kubernetes, nothing should be there. So we have completely cleaned up everything. So this completes the deployment section, and in our next section is going to be services, and then we will see services concepts in our next section. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to understand about one more Kubernetes concept named services. So we have multiple Kubernetes services available here, like cluster IP, NodePort, load balancer, Ingress, and then external name. So let's see one after the other what are they on a very high level. So cluster IP is used for communication between applications inside the cluster. Example, like you have front end and then back end application, and then they need to communicate each other, so we can use cluster IP. So the cluster IP's network range is inside the cluster, Kubernetes cluster. So let's see NodePort. So NodePort is used for accessing applications outside of Kubernetes cluster using worker node ports. So your Kubernetes, you have deployed an application in Kubernetes cluster and then you want to access it from your browser. So you can expose that as a NodePort service, so that using worker nodes respective port, you will be able to access outside of the Kubernetes cluster. And the next is the load balancer service. So primarily for cloud providers to integrate with their load balancer services. So example, if you take AWS, in AWS you will have something called Elastic Load Balancer. So how you are going to use Kubernetes manifest to automatically provision a load balancer in AWS. So you can do all those things using load balancer service. And the next is Ingress. So Ingress is an advanced load balancer which provides context path based routing, SSL enablement, and SSL redirect, and many more. Example, you can compare it with AWS application load balancer type of concepts. So it has all the HTTP based features available inside that which you can leverage. So in the same way, the next is the external name. So to access externally hosted apps or databases or something inside your Kubernetes cluster, so you can use external name service. Example, for your application which you have hosted in your Kubernetes cluster, you have a AWS RDS database, a cloud provider database, and if you want to access it, so using that respective database's DNS name, using external name service, you will be able to access that in your Kubernetes cluster. So these are the core things available here. As part of the fundamentals, we already looked into NodePort service. Now we are going to look into cluster IP service. In addition to that, combining NodePort and cluster IP, we are going to implement a front end and then back end one example so that we get a complete picture about NodePort and then cluster IP. And load balancer and then Ingress and then external name will focus on when we are doing the respective cloud provider courses. So let's move on and then understand whatever we have discussed in a pictographical manner. So let's consider in a Kubernetes cluster, you have deployed your backend application. Example, like some REST services application or whatever is your backend application. And this backend application is currently using a RDS database which is in AWS. So if you want to access that from inside your Kubernetes cluster, so you need to define a DB external name service here. In the same way, you have your front-end application, right? And then this front-end application need to access your back-end application. So for that purpose, you need to define your cluster IP service in your Kubernetes cluster. And now your users want to access your application here, okay, in the which is hosted in Kubernetes cluster. So for that purpose, you will deploy your front-end service, okay. So it might be a NodePort service or load balancer service or Ingress service. So based on the environment you are using and whatever is applicable for you, accordingly you can deploy that Ingress service or load balancer service or NodePort service. So all in all, this is the way we the services can be leveraged for us inside Kubernetes cluster in combination with external applications or internal applications. So in our next lecture, we'll go ahead and then implement our front end and then back end application with NodePort and then cluster IP. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to do the Kubernetes services demo. So let's see what we are going to implement as part of that. So in a Kubernetes cluster, we are going to do a backend deployment. So we have a simple Spring Boot REST services hello world service. So we are going to deploy it. As soon as we create the deployment, automatically its SQL and ReplicaSet and then pod gets created. So once that is done, we are going to create the backend app related cluster IP services using kubectl expose. So once we do that, so we will go ahead and then create the front end deployment. So in front end, we are going to create a Nginx pod, and in that Nginx pod, we will have a proxy to this respective cluster IP service of backend, which is nothing but my backend service. Now, for the users to access our application, we will also deploy the front end app NodePort service so that users will be able to access it. So let's go to our GitHub repo and we'll go to our 05 services with kubectl, right? So introductory section we already discussed in our previous lecture. So let's go on to our step 2, which is cluster IP service backend application setup. So let's deploy a simple backend application and then front it with a cluster IP. So the application we are going to use is a simple Spring Boot REST application, just a hello world REST application. So what we need to do if we want to deploy a application, we just need to create a deployment, and then front it with a service. So kubectl create deployment, my backend REST app, and the image of that, right? So let me copy this, go to my terminal, and then paste it. So it should create our respective application, right? So we can say pods to see our pod is running, yes. And if you want, you can even say logs-f, okay, kubectl logs-f, and then check the logs of our Spring Boot application. It should be up and running now. Started your hello world application in 3 seconds on port 8080, okay. So if you see here also, we have exposed, means like we are going to expose as a service with the port 8080, right? And the target port is also 8080. So we really don't need to mention target port 8080, but for our convenience, means like following a standard, so I just put it. In addition to that, you really don't need to provide when you are creating a service using kubectl imperative command expose, right? So you really don't need to provide type is equal to cluster IP here. Reason is cluster IP service is by default created by, means like it's a default service, okay. So we really don't need to specify that. If it is a type is equal to NodePort, yes, we need to specify, but for cluster IP we really don't need to specify it. So kubectl expose deployment, my backend REST app, port, target port, and my service name, my backend service. The service name is my backend service, okay. So now everything is created, kubectl get svc. So my backend stuff is completed now. So now I need to create a front-end Nginx reverse proxy, and then that Nginx reverse proxy should proxy to this my backend service. So for that purpose, I pre-built the container and then put it here. So if you go to our NodePort service, so in my Nginx conf, I have put in the proxy pass my backend service colon 8080 as the port, whatever we are seeing, right? My backend service, and then port is 8080, right? So if it is not in default namespace and then some other namespaces or something, again we need to give the full cluster DNS name, which is svc.default.svc.local, all those stuff we need to give. But as we are running in the default namespace only, okay, kubectl get ns, right? We'll list the namespaces. This is a different concept which we'll look into it later, but currently we are in the default namespace. We really don't need to provide any full cluster DNS host name here. So that's the reason, to make it very simple for you and not to confuse too much. So I just gave whatever is my cluster IP service name here. The same thing I have provided, right? And then I have pre-built the image and then put it ready. So in our Docker Hub, so we can directly use it and then run these commands, and then everything should work for you, okay? So and no, I want to create my own reverse proxy related Docker image, okay? Yes, you can do it. So I have provided the steps and the source here, kube frontend nginx. If you click on that, so it will take you to 00 Docker images, 03 kube frontend nginx, okay? So prerequisite is you should have your Docker account, and then you can create your Docker file like this. Everything is present in this v1 release, the Docker file, and which is nothing but from nginx you are taking your source image as nginx, and you are copying the default.conf whatever is there in the current directory to etc nginx conf.d, right? So if you see in v1 release, you will see the default.conf also here. Inside that you can see proxy pass, backend cluster IP service name, and then port. That's what you have put it here, okay? So the same thing, and you can go here and then review these things, and then after that you can go into this v1 release folder, right? cd to v1 release, and from there you can build it, docker build -t and your docker hub id and the kube frontend nginx :1.0.0, and take the files from the current directory dot, okay, and then push that to your docker hub id, and then you can start using it if you want, okay? So but for me, like, you can leverage this current whatever the Docker image, and then you can continue, but it's up to you. Just I have given why, because it is nginx, right? So I didn't give any steps for related to Spring Boot related application. Why? Because again it might confuse you and then create complex stuff, but here for nginx it's a simple thing, right? So you can try out your Docker skills there with those steps, and then come back and then leverage that here so that you will be more confident. So for that purpose I gave the detailed steps for Kube front-end Nginx building. Okay, so now a lot of things we discussed it. So let's go ahead and then create the front-end deployment and then create the front-end, expose that as a service. Okay, kubectl create deployment, my front-end Nginx app is my deployment name, and the image is kube-front-end Nginx. Okay, so let's take this and we are here. Okay, created, right? And now let's go ahead and then expose it, right? So clear kubectl get pods, both pods should be running now, and get svc, we should have two services related to backend service and then front-end service with NodePort and then NodePort ID. So if you want to access your application, so you can say get nodes and -o wide, right? And take the public IP here, and 32209 is our port. So let's go to the browser and say okay, and /hello, right? Sorry, so the IP colon 32209 is my port, and then /hello is the context, right? So we got the response. So let me make it bigger, and if you see it here, 32209 is our NodePort port, and then /hello. So that is the thing. So the same thing we have done it, 32209, and the context is /hello. Good. So now what we are going to do is, so we are going to scale our backend application so that how the load balancing happens, and then you can even see different values here. Where is this? Here, right? So this container ID, right? So this is going to change continuously. So whenever you refresh the browser. So let's test that for our convenience. Okay. So kubectl scale -- replicas is equal to 10 and my backend application. Okay. So I'm scaling my backend application. So let's go here and then scale it. So now kubectl get pods, my backend should be 10 backends I should have, right? So it's coming up. So let's, okay, so all are up and running. So now let's go ahead and then test that now. Okay, so where is this? Here, right? So I'll keep saying refresh, right? Okay, so we can refresh it. Something, okay, see, you can see this is changing continuously. H60 MB now. So it's load balancing across all the backends, right? 9G VFM WNZZ. So like this you are seeing all the containers are up now and then healthy. We are not even seeing that error. Okay, so VFM WG. Okay, so you can see how it is going on. So that's about it. So we have completed our services demo successfully. And one thing here is we really didn't look into load balancer and then external concepts here. So these things we will look into as part of our series of courses, whatever we are doing for AWS, Azure, and then Google Cloud. So in those things we will extensively look into this stuff. So I'll see you in the next lecture. Until then, bye bye. Thank you.